Hi guys, this is biology lesson 3.05 over osmosis. So we said that in the overview, osmosis is the diffusion of water. Diffusion of water. But there's some special implications to this. By the way, we're at the bottom of page 4. So we have this diagram that we haven't done anything with at the top of page 4. I had to redraw mine because I couldn't reuse the page. So we're going to be talking about this diagram as it relates to osmosis. On this page, you should have that the solute is the substance that is dissolved in water. And on our diagram, the little red dots represent our solute. It could be, a lot of times it's sodium, it could be chloride, it could be potassium, it could be anything that we dissolve. Another definition that you're going to want to use is the solvent. The solvent is the substance that dissolves the solute. Substance that dissolves the solute. And in the case of biology, the solvent is almost always water. So we have two tubes here full of solute and solvent. We're going to call our red dots our solute, and I tried to do a little blue line here so you can see. And this is our starting condition. And this is our ending condition. So a lot of solute is too big to get across the cell membrane. And let me label what I have going on here. So here and here. This is what is called a semi-permeable, P-E-R-M-E-A-B-L-E, semi-permeable membrane. What that means is only small substances can cross the membrane. Only small things, only very small things can cross. And guys, the cell membrane is a semi-permeable membrane. And that's why we said in the last video, only oxygen, carbon dioxide, and water can get across that membrane. So everything else that's represented here, let's say, let's pretend that these red dots are glucose. Think about the formula for glucose, C6H12O6. So there are 24 atoms. Think about something small like water. So our solvent is water. 3 atoms. Do you understand that water is much smaller than glucose? So water can cross this membrane, but the glucose can't. Now we defined in our last video concentration as the amount of substance in a given area or volume. So let's say I have 10 mils of water on this side, and I have 10 mils of water on this side to start with. If I count my dots, I have 18 glucose molecules in 10 mils of water. So I would have 18 molecules over 10 mils of water. So if I divide those two, or if I come up with a ratio, my ratio here is 1.8. And this ratio represents concentration. If I count up my glucose molecules over here, this is also out of 10 mils, I have 9 glucose molecules over 10 mils of water. So my concentration on this side is 0.9. So I have half the concentration as I do on this side. This makes sense, right? So look at how close these dots are. Do you see that we have a pretty strong concentration? So let's do this at the beginning. We have our left side and I have my right side. I've got a 1.8 concentration on the left and I have a 0.9 concentration on the right. And by the way, this is an actual experiment. It's called a YouTube experiment. So at the end, what's changed? Make some observations. Did you say that the dots look evenly spread out? And if you did, you'd be correct. Did you say that the water level has changed? You would also be correct. What didn't change? Did you say the number of dots? I still have 18 dots on this side, and I still have 9 dots on this side. So over here, I still have 18, and I still have 9. But I have different volumes of water. On this side, I have 13.5 mils of water. And on this side, I have 6.5. And I forgot to divide these out. And guess what? That gives me about the same concentration on the left and the right. If I take 18 divided by 13.5, I get about 1.34. And if I divide 9 by 6.5, I get 1.34. And you can see that the concentration's even. How did this happen? I couldn't move my solute, but my solvent could. Glucose can't get across this membrane, but water can. So our takeaway is the water diffused from the left side. Whoops. I don't know my left from my right, guys. The water diffused from my right side into my left side. That's why we give water its own category, because we have to think about it a little bit different. Because when the water diffuses, water will always diffuse to equal out the concentration. So in osmosis, and let's just write that down. We could say it as the water diffuses into areas of higher concentration. And that's a little bit confusing because we said diffusion is always going from areas of high concentration to low. But think about it. What we're doing here is by the water changing, we make the concentration even. So we really are concerned about the concentration of glucose. So in this case, the water is the equalizer. The water, it's like if you've ever had a party and you got or Christmas, you got a small gift and your brother got a big gift and your grandma felt bad, so she gave you a little extra cash on the side. Grandma is the equalizer there. So that's what water does. When water diffuses, it looks like it's going against the concentration rules, but what it's doing is it actually is evening it out. I think what we're going to do is we're going to run this in a part 1 and a part 2. So let's add this. Oh, I'm off screen. Part 1. And we'll talk about how this applies to cells in part 2. So our takeaways are that we have water's the solvent, and in this case, glucose was my solute. Water will diffuse to where the solute is more concentrated in order to dilute it. So the word we want to use here is diluted. We diluted this side of the concentration. And then has some specific applications for cells. Also, we talked about the fact that there's a semi-permeable membrane here, and cell membranes are semi-permeable. Okay, so on to part 2. Thanks for watching.